So today's presentation is on 3D printing, and I'm going to be giving an overview of the different technologies that are used in 3D printing. And we're not going to cover so much on the aspects of the models or the computer software, but more of the hardware that is used during 3D printing. So to start with, the common types of 3D printing that you'll find there's three of them that I'm going to cover, and we're going to start with fused deposition modeling, or FDM. Now, this is your most commonly known to hobbyists and the most wide-ranged, I would say, way of 3D printing, and it can be used from anywhere from hobbyists to professionals. Well, what it is you're using industrial grade or engineering grade thermoplastics that are spooled in giant spools of like 0.5 millimeter thick strands, like a really, really long spaghetti noodle, which is fed into the printer, heated up until its melting point, and then it is extruded out from that nozzle onto a flat surface, and it is built from the ground up. These models sometimes require supports if the model has any sort of overhang or extending outward parts, and can be used with a variety of different types of material, which I will cover later. These types of printers can cost anywhere from $300 to $10,000, depending on what type of printer you're going for. The hobbyist grade ones are $300 to $500, while your highest up one is your industrial grade one, the ones you'll find in production facilities, laboratories, and other places where they're doing 3D printing for parts for larger industries, such as printing parts of cars. You'll find those $10,000 3D printers. Next up, you've got stereolithography, or SLA, which is also a common one that is used both hobbyist and professional. It's not quite as known, I would say, and instead of using your thermoplastics, you are using resin. So you're using a liquid or mostly liquid type of plastic that is poured into a vat with a clear bottom, and then depending on which type of resin you're using, it is usually a ultraviolet radiation light that is shined on the resin, which hardens and solidifies it onto a build platform that slowly rises out of the resin pool. So as it rises, more of that resin is solidified by the UV light. And this method of doing 3D printing always requires supports for whatever you're making. And again, it costs from $300 to $10,000 depending on what type of printer you're doing. The hobbyist grade printers you can find at $300. You can pick one up off Amazon, while the industrial ones, which usually also come with your post-print aspects of doing the chemical rinse that's needed on them, much higher priced, around the $5,000, $10,000 range, depending on how expensive you're going for. These types of printers usually have smaller build volumes than your FDM printers, so you can't make as big of objects in them, but they are much, much more detailed because they are using a light to solidify parts of the model rather than a nozzle with a certain thickness of plastic, which can only focus so much. And lastly, the last one I'm going to cover is selective layer sintering, which is definitely a more uncommon version of 3D printing that you do not find really anywhere besides industrial grade 3D printing manufacturing. How it works is you've got vats of particles, and they're on either side of where your print bed is, and a roller will roll a new layer of particle over top of your build plate, and then a laser will graft whatever that layer is into the particles and solidify that section of the particle. The roller will roll over it again, spreading a new layer of particulate, and then the laser will graft it again. This method does not require support because the build is always surrounded by a giant container of particulate. However, when you finish the print, you have to chisel it and dust it off like you're doing archaeology and get rid of all the excess dust to get your actual final part out. It is very accurate and can have very large print beds, but it also requires a lot of the post-processing of it. It has a very wide material range, wider than your FDM or SLA types of printing. You can do anywhere from ceramics, glasses, and metals to other types of plastics, and anything that you can turn into a particulate dust matter, which can be sintered together by the high-powered laser that is used in this method of 3D printing. Now, I'm going to move on to your common 3D materials. And this is in a different section than just covering it with the types of 3D printing because these materials are shared between different methods of 3D printing. You've got polymers, which are your basic thermoplastics, and your thermosets, which are thermoplastics, as I said before, are your types of plastic that are in the giant spools and are melted and then resolidified, while your thermosets are your liquid resin-based plastics, which are solidified with either ultraviolet radiation or high heat, depending on what type of thermoset you are using, but is usually ultraviolet radiation. For your thermosets, this type of plastic is usually used in FDM or SLS printing, and if it is in SLS printing, it is a particle rather than a solid strand. Common types of thermoplastics include, you have your PLA, which are common, low cost, not suitable for high temperatures. It's your cheap prototyping plastic. You've got ABS, which is just an improved version of PLA. It's more durable, better thermal resistance, better impact strength. It's what you would find people using if they were trying to build solid plastic final product parts. They would be using ABS for that. And then you've got TPU, which is a type of plastic which has elasticness and it's got low hardness and a rubber-like feel. It's the type of plastic that you would find used with things like phone cases. They've got that flexibility in them, and they're durable. If it's not a rubber phone case, it is probably made with TPU. Now you have thermosets, which are your SLA printings, and as a side note, Kuro, I have a print of that, the second one, in the same material. Yes, I'll send a picture when I'm done. Back on track. The SLA are your liquid resins. So essentially, there's one type. It's liquid resin. It's just a liquid plastic that is solidified. Next up is your metals. Stainless steel and aluminum are the two commonly used types of metals. If you have a very specialized FDM printer, there's some FDM printers that are specialized for metal printing. You can print these types of metals, and I think you would find them more commonly used, though, with your SLS printers and having them with particulate. And finally, the other materials type you've got glass mat thermoplastics, which are GMTs. They are essentially sheet metal, but better. And then you have advanced thermoplastic composites, which are just polymers that have been modified and can be customized beyond whatever. It can be customized to fit specific situations that the manufacturer needs for that material. And both of these can be customized to a degree. Your HEC is better for customization. You have more options with that, with interchanging different types of plastics in the compound. But definitely both of them are your more expensive and improved versions of your regular thermoplastics. And these are some of the sources that I used to get this gather this information. Finally, thank you all for listening. Have a wonderful week. And if you ever get into 3D printing, I would recommend starting with a FDM printer. Unless you're trying to do detailed miniatures, then go straight for your SLS. And that is all.